Welcome back. In today's video, I'll be describing how the various significant factors of mental illnesses, antidepressants, sugar, and physical exercise all alter the brain's chemistry. Now let's get started. To begin, I will cover mental disorders. But before we start, it's important to understand the science behind these disorders before we take a deeper look at them. Now, common illnesses such as OCD, depression, and anxiety all stem from certain traumas in one's life, but they all lead to one or more of three complications within the brain. As I list off these three possible conditions within the brain, please keep in mind that they all involve serotonin. Serotonin is the neurotransmitter or chemical messenger responsible for joyfulness, contentment, and emotional stability, all within the brain. So without further ado, let's get into the science. The first problematic scenario that may be present is there is too little serotonin being released into the synaptic cleft. The second possible issue is that there is too much serotonin reuptake. And the third possible condition is that there is an improper serotonin receptor response. Okay, I've taken a seat and pulled up a diagram on my monitor here because this is where the content starts to get in depth. So here we have the presynaptic neuron and it's following postsynaptic neuron. And in between is the synaptic cleft. And these circles are called synaptic vesicles. Inside of the synaptic vesicles, we have the blue dots, which are the neurotransmitters known as serotonin. So, to describe the first possible dysfunction, this is when there is not enough serotonin being expelled from the synaptic vesicles and released into the synaptic cleft here. Therefore, not being able to bind on the postsynaptic serotonin receptor. Alright, we have now reached the third and final complication within the brain. And this is, as we discussed before, an improper serotonin receptor response on the postsynaptic neuron. So, from my own research, I found that this is most commonly the oversensitivity or insensitivity of the serotonin receptors. And I'd like to explain that the most common reason for a desensitized serotonin receptor is SSRIs. SSRIs are selective serotonin reuptake inhibitors. You may know these as antidepressants. So, the antidepressants, or selective serotonin reuptake inhibitors, supply such an extensive amount of serotonin to these serotonin receptors for a long period of time that the brain adapts by desensitizing its receptors. And this is problematic because now the brain needs more stimulation to activate these receptors because they have become desensitized. Allow me to explain. This structure here in the center of our brains is known as the amygdala, as we said before. And it is the brain's fear center. So the oversensitivity of the postsynaptic serotonin receptors causes the overstimulation of the amygdala. And when the amygdala is overstimulated, it triggers fear. And this fear, of course, triggers anxiety, restlessness, and even panic attacks. Okay, now that we have covered the three chemical complications of mental illnesses, we can now move on to the topic of how sugar negatively affects depression. Do you know that feeling you get when you eat a sugary snack? I'm sure you do, because it happens to me. Now that is a dopamine release. This sugar-related dopamine release is intense and short-lived. And if you're addicted to sugar, you reinforce this dopamine spike every day over the span of years. And similarly to the serotonin receptors, the dopamine receptors in your brain adapt by desensitizing because there has been a constant flood of dopamine, in fact artificial dopamine to them. So the brain initiates dopamine downregulation. To define dopamine downregulation, it is the process in which postsynaptic dopamine receptors become less responsive to future dopamine release. Now, this is actually the brain's protective defense mechanism against the unwanted feelings of natural pleasures feeling understimulating. And dopamine downregulation can actually indirectly contribute to lowered baseline serotonin levels. I've looked up an animated image to elucidate the concept that dopamine downregulation indirectly contributes to lowered serotonin levels. So if we look here, Dopamine is the reward chemical. I call it the motivation chemical because it is responsible for the anticipation of reward. So if one's postsynaptic dopamine receptors are desensitized, they're going to receive less motivation. This less motivation is going to contribute to less accomplishments and eventually dissatisfaction. So let's take a break there. We see serotonin, the neurotransmitter responsible for mood stability. And this dissatisfaction allotted from dopamine downregulation is actually lowered serotonin and sadness. Furthermore, immediately after giving into a sugar craving, your body experiences a slight rise in serotonin levels, which contributes to feelings of relaxation and contentment. But this means that someone who is addicted to sugar or compulsively digests sugar on the daily actually has lower baseline serotonin levels. And the reason for this is because the consumption of sugar increases insulin levels, and insulin is the hormone responsible for increased tryptophan transport across the blood-brain barrier and into the brain. Tryptophan is the amino acid precursor to serotonin. So this means that the more tryptophan, the more serotonin synthesis. And after consuming sugar, due to the increased amount of tryptophan, there is an increase in serotonin synthesis. And this immediate and temporary increase in serotonin causes the brain to desensitize the postsynaptic serotonin receptors. And ultimately, this is deleterious to the body because then the body needs more sugar to achieve the same levels of satisfaction. Lastly, when the brain recognizes too much or too regular artificial serotonin production, it reduces its own natural serotonin synthesis. And to explain this at a deeper level, the serotonergic neurons in the Raphe nuclei synthesize less serotonin. But this is bad because the less serotonin produced results in depression, anxiety, and emotional numbness. So in conclusion, I'm trying to convey the fact that high sugar consumption can negatively affect mental illnesses. And this guides us perfectly to our next topic, which is how antidepressants work. The most commonly prescribed form of antidepressants are SSRIs. Now, SSRIs stand for selective serotonin reuptake inhibitors, and a prime example of an SSRI is sertraline, which is what we will be taking a look at today. I will now elaborate on how sertraline provides short-term and long-term solutions to each of the three complications within the brain that we discussed previously, which arise from mental disorders. First off, my research concluded that hypersensitive presynaptic serotonin autoreceptors are the problem that cause little serotonin to be released into the synaptic cleft. So these receptors are on the presynaptic neuron, the autoreceptors, and I want you to be conscious of that because what we've been talking about in the past is the receptors on the postsynaptic neuron. Anyways, the hypersensitive presynaptic serotonin autoreceptors do not permit the proper amount of serotonin to be released into the synaptic cleft. In response to this problem, sertraline combats this by desensitizing the autoreceptors and therefore allowing the proper amount of serotonin to be released in between the neurons. According to my research, sertraline performs this task by supplying the presynaptic serotonin autoreceptors with an abundant amount of serotonin, thereby causing them to desensitize and allow the proper amount of serotonin to reach the synaptic cleft. So, when a person weans off the medication, the autoreceptors will remain desensitized and the problem will be fixed. Second, my explanation of how sertraline counteracts too much serotonin reuptake is this. Here displayed on my monitor is a diagram that will help us better visualize the function of sertraline. So, the medication sertraline inhibits the performance of the serotonin transporter. And by doing this, it inhibits the serotonin reuptake transporter protein from collecting excess serotonin neurotransmitters and returning them to the presynaptic neuron. The result of this is that more serotonin stays in the synaptic cleft for a longer period of time, and serotonin's capability to bind to the postsynaptic serotonin receptors and send stronger signals to the brain is heightened. To put this in more simple terminology, the more serotonin available to bind to the postsynaptic serotonin receptors, the more enhanced serotonin's mood regulating effects are. That's short term. Now it's time to explain how sertraline can help too much serotonin reuptake long term. And the answer to this question is that sertraline increases BDNF and improves mood regulating circuits within the brain. So these effects actually last after a person stops taking the medication. Third, to address the condition of an improper postsynaptic serotonin receptor response, we must take into perspective the insensitive and the hypersensitive serotonin receptor. So luckily, in each of these cases, sertraline can be useful. Okay, so take into consideration the example that the postsynaptic serotonin receptors are insensitive. While on the sertraline, the medication, serotonin signaling will be increased and hyperstimulate these serotonin receptors. Eventually, as a person weans off the medication, the serotonin signaling will drop and the brain will react by hypersensitizing or resensitizing these receptors. On the other hand, in the case that postsynaptic serotonin receptors are hypersensitized, sertraline will provide a strong serotonin signal to these receptors and cause them to downregulate or desensitize. As a person weans off the medication and eventually quits, these effects will remain and the problem is resolved. Okay, now it is time to discuss weaning off of SSRIs. Weaning off of SSRIs increases the sensitivity to serotonin naturally and enhances serotonin signaling. This slow process of tapering off an antidepressant or an SSRI gives the brain time to adapt through adjusting its postsynaptic receptor sensitivity and rebalancing neurotransmission naturally. This slow process prevents withdrawal symptoms and to a further extent prevents SSRI discontinuation syndrome. For a brief moment in the video, I'd like to expose a commonly misunderstood feature of SSRIs. Many people believe that serotonin is within the pill. However, this is incorrect. There is no serotonin in the pill, but when the pill enters your body, passes the blood-brain barrier, and enters the brain, it alters the way that the serotonin that is already in your brain is used. Okay, we have now reached our final topic in the video, and this is how physical exercise affects the neurochemical balance within the brain. Let's begin. Here is the first benefit of physical exercise on the brain, and it is that exercise stimulates natural dopamine release. This is why you feel a sense of accomplishment after completing a strenuous workout. The second advantage of exercise is similar to what we talked about before, and it is that exercise boosts tryptophan uptake in the brain, so ultimately exercise means more serotonin synthesis. Moving down the list, we have the third benefit of exercise, and this is that exercise releases endorphins, which allow you to feel pleasure, especially in cardiovascular activity. But the list doesn't stop there. It keeps on going. Physical exercise creates new brain cells in the hippocampus, increases its volume, and improves long-term memory. Physical exercise also encourages the release of noradrenaline, or norepinephrine. Norepinephrine is the neurotransmitter responsible for alertness and focus. This is a perfect example of why I like to take breaks in between my studying sessions to work out, because it helps me reset my focus. Additionally, exercise lowers the stress hormone known as cortisol. We have now reached the last positive effect of physical exertion, and it is that exercise boosts BDNF. Here on the screen, I have a diagram to represent the relationship of exercise and BDNF. So, as one does exercise, BDNF is increased in the brain, and this prompts two processes, which are neuroplasticity and neurogenesis. I will define each term. Neurogenesis is the regrowth of neurons, whereas neuroplasticity is the positive rewiring of the brain. In addition to these two positive effects, BDNF also triggers the stronger connections between neurons and better communication. Okay, those are the neurological conditions behind mental illnesses and how sugar, antidepressants, and physical exertion affect them. That brings us to the end of the video. Thank you guys so much for watching.